Okay, so here we go. We're going to try our next challenge, which says determine the 11th term of -3, 6, and -12. Okay, we know the story, right? Where we always want to start off by writing down our sequence. -3, 6, and -12. Okay, now remember, we're working with two different types of sequences at the moment, arithmetic and geometric. Arithmetic needs a common difference, like a first common difference, and geometric needs a common ratio. Now, just quickly, let's think about this for a second. I, generally speaking, will go for arithmetic to do the testing for arithmetic first because it's the easiest, right? And then we work our way down the list on seeing which type of sequence this is. And with time, eventually, you're not even going to have to do that step. You will simply see that this is geometric or simply see that this is arithmetic, which is quite cool, right? So practice makes perfect, guys. Cool. So at this stage, let us do our testing. Why not? Okay, arithmetic testing. What do I do from -3 to 6? I need to do a +9. What do I do from 6 to -12? Well, wow, we got a minus here actually. We got to subtract 18. Okay, this is definitely not the same difference, right? So it is definitely not an arithmetic sequence. Cool. So that just takes us to the next step of testing, which is to test for geometric sequence. Now, we have a cool little trick where we say T2 divided by T1. Alright, so let's check. What is the value of T2? Well, can you remember how the T's and all of this madness works? Let's check it out. -1 is T1, -3 is T1. And remember, T1 represents term 1. Term 2 has a value of 6, and term 3 has a value of 12. Alright, so let's plug in that information. Term 2, which is 6, divided by term 1, which is -3, and that gives us -2. Okay, let's double check that our ratio is constant. And how do we do that? Well, the same way we did this a moment ago, except we're just going to use different ratios. This time we're going to say term 3 divided by term 2. Okay, let's check if we get the same thing. Alright, term 3's value is -12. Term 2's value is 6. And let's check it out. A negative, bam, and 6 goes into 12 too. Okay, so we know that our ratio is definitely -2 because it's been the same in both cases, okay? So it's a constant ratio. Now let's talk about what is the standard formula that we would use in order to create a general nth term. Okay, let's check. We have Tn is equal to AR to the power of n minus 1. Notice that minus 1 is in power form, okay? It's in the exponent. Alright, cool. Let's talk about the other variables that we have here. The nice thing is, as it did for arithmetic, it's going to do the exact same thing for geometric. It's going to represent the value of the first term. And in this case, we have -3. Brilliant. Okay. Now the R, which is awesome, okay? R is the ratio. Quite easy to remember the association, ratio and R. Okay, and we already have calculated what that is, and that is -2, because we're amazing. Okay, now we're going to go into creating what our general nth term is, okay? Again, we've ignored the n, right? Because that is only, it's only going to be used once we have our general nth term. Okay, so let's go ahead and see how this goes. So we got Tn is equal to A, and A we've said is equal to -3. I'm going to put it in in brackets because it is a negative number, okay? Then it says A multiplied by R. So again, open brackets, -2. Okay, so we have -3 minus -2 to the power of n minus 1. And that's it. That is our general term for this equation. Now, this is wonderful that we've gotten this far, but what we need to do is test it, right? Because we can't just jump into the lake. We've got to know that it's deep enough before we do something crazy like that. So let's go ahead and decide which term value we're going to work towards. Now, you guys know already that T2 is my favorite one because he's in the middle. Piggy in the middle. All right, so let's go ahead and do that. So we have T, and remember the term position we're going to place into the n value, okay, into the position, well, substitute into n. So we're doing t2, which is cool, is equal to, and now we have -3, -2, and then we have another n, so we have to plug in a 2, and then we have -1. Cool. In a case like this, always start off by cleaning up your exponents, all right? Remember your BODMAS rules, which I like to call BEDMAS, but we'll chat about that at a later stage. Okay, so let's see. 2 minus 1 in exponent form is just going to leave it to the power of 1. So we can literally rewrite it as -3, open bracket, close bracket, -2 to the power of 1. Now remember, guys, if we don't see an exponent value on numbers, it means that they're all actually to the power of 1. So it's really not important for us to do this one here. We could just leave it as is. Oopsie daisy. Talk about the biggest eraser on the face of this planet. Let's go for something smaller. Get rid of it. There we go. Okay. And that's quite simple. Let's see. We have negative times a negative, which we know is going to give us a positive, and 3 times 2 is going to give us 6. So our answer should be +6. And let's see, do we have a +6 for term 2? Yes, we do. All right. So now we're going to follow the exact same process, but this time we're going to finish off the challenge. They've asked us to calculate the 11th term. So following the exact same process, except this time where we see all the n's, we're going to put an 11. Okay, so here we go. T11 is equal to -3 multiplied by -2 to the power of n. In this case it's going to be 11 minus 1. Okay, so here we go. Doing the exact same thing as we did previously. We're going to sort out the exponents first. So it's still going to be -3 multiplied by -2. And to the power of 11 times minus 1 is 10. Easy. Okay. Now, obviously, right at the beginning, where we have we actually have that whole first sentence, we could plug that into our calculator and simply get an answer. I like to just show exactly what is happening so that when you are in an exam and time is of the essence and you're using your calculator, you understand what is happening in the background. Okay, that is a very important part about maths, is understanding what's there, and eventually we don't have to see what's happening there because we know it, we understand it. So -2 to the power of 10 is going to give us 1024. Okay, and then we simply multiply that all by 3, so it's going to be -3072. Okay, that is the value for the 11th term for the sequence.